So one nice thing with 3D printing is you can make, custom things. Like this is just a little organizer for the bedside table, and I can just make new ones and slide them on. We bought a new thing and it doesn't fit in the old fitting, so that means sometimes you get to design a whole new holder to go on the bedside. In this design, I had to measure and then try a few test prints to get the space right for where it fits on the edge of the bed table. Obviously, it's not going to fit this desk drawer that's out here. And I had to make sure it had enough room for a couple of pieces of felt. I originally had felt on the top too, but then that made, when it sat on the bedtime, it made it sit too proud, too high up. So I've designed them to just have felt on the back and in the bottom of the fitment. And this square piece here in the design software is a single component, so I could just reuse it. And then for this, I'll probably just modify the design that was there for the smaller bottle. As usual with most 3D design, you just spend all of your time with this. So always taking, so this is 34.45 millimeters. And I could check the height, but it looks to me like that the height that's there is going to fit. And if I look at what was in there before, it was probably 30 millimeters. So I need probably 36 millimeters to be able to fit this bottle. So 36, if I get it just a little bit up there, gives me a little room for it to wiggle in. The editing software, Fusion, by Autodesk. They've been making AutoCAD software for decades. And you can see I have a whole project that's just on bedside storage. And down to that, I got a tissue box holder and I think it'll hold a mentholatum and nasal spray and the TV remote, the flashlights. So this is looks like the one that was used before. It held an Afrin bottle, and they're smaller diameter than whatever these new knockoffs are for nasal decongestant. So one of the things that makes it easier to use this software is this is a 3D mouse. So it can move in 6 directions. I can tilt it back and forth. I can actually push it back and forth. I can push it side to side, or I can tilt it side to side. I can twist it, and I can pull up. And what happens on the screen when I do all of this is I'm just with my hand here, I'm able to rotate this in all of its dimensions. I can zoom it in and out. Again, move it side to side. A lot of times when you do one movement, you get another, like quite often it zooms when I'm just doing something like moving side to side. And you tend to look for mistakes and artifacts that show up. But so this really makes doing this kind of design a lot easier. I just had this for a couple of weeks now, this what they call a space mouse. But sure has made it easier to design this software. One of the things you find out in 3D printing and design is that everything's really made up out of very simple things. So what you're going to see here on the screen is some kind of wireframe that I've put on top of. This is what the base design was, and it's then been extruded to make a third dimension out of it. So there's really, this entire assembly you see here is just made up out of 2 things. This square with a circle in it and an edge around it, and then another kind of U-shaped set of squares that make that assembly. So what we're going to do is we're going to take this circle assembly and see if we can push it out to 36 millimeters. If it doesn't fit, then we'll have to also widen the other one. So here's editing that two-dimensional design to get that eventually becomes a 3D design. And one of the things I discovered was that I was thinking ahead when I did this a year ago. And what you can see here is the dimensions of that opening says it's the dimensions of an Afrin bottle OD, or outside diameter, plus 2 millimeters. So that means this entire design is parametric. And so it's controlled by parameters. And if I find the Afrin bottle diameter, I can change it from, so currently it's 30.5, and it says in the display it said it added 2 millimeters to that. So I know the new one is 34. And 34.5. And as you can see, it's automatically adjusted not only this diameter, but it also adjusted this height. And if I finish out here, and I finish out of the sketch, I'm actually done. The heights of everything has already been adjusted. So including the width of the other shape. So when I was designing these things a year ago, it's been a year since I've had to make a new one of these. Apparently I was really on the game, because I made sure I could adjust everything just from changing the numbers. So this is a design that's ready to print. So to be honest, all I have to do is just select the whole body, find it here in the display, and I'm gonna say File and 3D Print. And over here I'm just going to check the settings, but it says it's going to send it to the Cura print utility. And I say OK. And it's now going to go to the print utility, which starts up. So I've gone from design to now I'm going to go into construction. So you use two pieces of software. There are some softwares out there that you don't have to switch. It's all contained in one. But there's various reasons for wanting to have things in two parts. Cura is not the only producing software I use. So again, I can use the 3D mouse and see what I'm going to print here. And one of the things I'll want to know is this really the best way to print it? Should I, print it on its sides? It all depends on where support's going to be and things like that. I think in this one, this is going to make the most sense just to print it this way. So we're gonna say, well, get this ready to go to the printer and show me what it's going to look like in the printer. And what you can see is, it's added supports. You can't just print plastic in the air, right? You'll see when the printer is printing, it starts down at the bottom and then moves its way up. In fact, I can, using this piece right here, I can actually show you how this piece is going to print. So it's going to start at the bottom and print its way up. And notice how the supports are printing as it goes up. And then the supports print that, the middle of it. And then you keep going up and another set of supports print that. So when I'm done printing, then this set of supports and this set of supports will get broken off. And they're printed with a very small gap in between them. So they just barely touch. And they're printed at a low temperature, so they don't adhere very well. So that's the other secret to 3D printing, is how supports are managed and made. And because it printed this way, they didn't need any support for that big old circle in the middle. If I had printed this on its side or something else, I would have had to support the circle. And you don't get a very round circle when you support it. But brackets and square things, well, supports work pretty well on them. So we're actually going to print this way. So this is the actual 3D printer. You can't print paper or anything. It's just for printing plastic. I just got it in the office on top of my stack of a library catalog that actually is full of 3D printer parts, electronic parts, spare cables. So in this case, I'm just gonna have it redetect its home positions, and you can see the bed moves in an X and a Y, and then the head itself goes up and down in a Z. So you have X, Y, and Z. So that's your 3 dimensions. And over here is a spool that's in a dryer. And plastic has a bad habit of, if it gets moisture into it, and plastic does absorb moisture, this particular plastic is plant-based, so it's recyclable. It's made out of the same thing out of bottles, the clear bottles you see. And this has coloring added. This happens to be a black spool, and you can see here's a spool of green, and just comes in lots of colors. I've got, maybe half a dozen, maybe 8 or so of these colors. This is PLA, which is polylactic acid. So the things that plant proteins are made out of. So this is what's going to do the printing. And then I have a camera mounted on the side, and I guess you can see it a little bit. On the camera are a set of cheater lenses that you can add to things like sunglasses. If you need reading glasses, you can add these. And these webcams, like this one, they tend to be a little far-sighted in that they like seeing things far away, but they don't see things near very well. So I've taken a cheater add-on for sunglasses, which are just made out of a kind of filmy plastic, and stuck it over the lens so that I can get better focus, because I want to be able to see when this is printing right here in this area. And so one of the things I can also do is, this will take a snapshot every time a layer is finished. And so I'll make a time lapse of this cup being reprinted now with the new size. So here's the printer putting the initial layer down. I think in this case it first lays out kind of an outline area to basically cleans the head and stops you from having dust and contaminants come into the print around that area. He just prints just a layer of it, and each of these layers is only 0.2 of a millimeter high. It can go as low as 0.08 millimeter in height. And as you saw in the drawing, it's going to print a lot of these little circles that are going to be the supports. So that's what it's doing right now. And this is just the first layer. There's 250 layers, and that's why it's going to take this thing 4 hours. I've not sped up this particular printer. There are things you could do to make them print faster, and I just haven't taken the time to tune this one to those parameters. So I could probably get it to be at least twice as fast, maybe 3 times as fast. And you can see there, those are just supports that are going to be put in here. And here's the actual outline shape of the bottom of it. And remember, it's got a bit of a square and then a circle inside it. So with the time lapse, you'll see all of this being printed. I think it'll take a picture every time the head moves up the 2/10 of a millimeter. Right now it is filling in that area. You can see it doing it there. And this is going to be, the base of it is completely flat, so it's going to fill this whole area up. Then as it prints higher, it's going to print holes in it. Going back to the software that shows what we're printing, and we can see here, this is what it was doing on layer 1. Did those circles that are going to be so that it can build up those supports, and that big base area is the actual base. And if I just take my slider and start to move up, you can see where it's just not going to print where the cylinder is. And notice it's printing the supports. It's printing a lattice on top of the supports, and that's what's actually going to hold up that first shelf, and then it'll finish that shelf as I move up. And so this is the printer every time. It's just moving up and printing a layer's worth, moving around in the XYZ dimensions until it gets done. And then that's the full piece. And as I said before, then when it gets done, we'll just break off those supports. So this is with the supports off. They actually came off pretty easily, came off in one piece. And as you can see, these are called tree supports. And they grow up into these trees. And it prints a mesh on top of that. And then if you take a look, there's a little pattern on the bottom of the plastic. So usually I plan which way I'm going to print something also based on where will the supports be. If they're going to be down where you can't see it, like this sits here, you'll never see where those supports were. So you get a very fine finish. I could have turned on a finer finish for the top. I didn't think about it. And this line here is caused by, that's where it starts each layer every time. And you can also turn on a randomizer so that gets spread out over the whole display. But most of the time I just like to see the line. I don't mind it at all. So that's that piece, and there's those. And oops, as we can see, we got the dimensions good enough. A little play on the sides and everything printed up. So yeah, now I just have to put the little felt in on the back and the bottom, and that should slip right in, and I got a new holder for the bedside.